Hello, space fans, and welcome to the 4th anniversary edition of Space Fan News. This week, I'll present some highlights from the 227th meeting of the American Astronomical Society. Okay, so 4 years and 147 episodes ago, Space Fan News was started as kind of an experiment to present the discoveries that were being announced at the winter meeting of the American Astronomical Society. So the idea was to do one SFN every day throughout the meeting, and then I was going to stop. I kept going though when people said they'd like to see it continue. So what I did was I set this arbitrary number of views that if they were exceeded, I would continue doing it. And I set that number at 1,500. I don't know why, thinking that I guess that size of audience would make it worthwhile. Well, we've done a little bit better than that, folks. So except for a hiatus while I did other things for a while, we've been pretty much non-stop space news every week since. All right, let's get to some of the meeting's announcements. Now, I'm making this episode on Wednesday, so I'll be missing some of Thursday's stuff, but I'll include them in next week's episode if they're interesting enough. And the emphasis is on interesting. Astronomers using NASA's NuSTAR, the Nuclear Spectroscopic Telescope Array, have captured the best high-energy X-ray view yet of a portion of our nearest neighboring spiral galaxy, Andromeda. The space mission has observed 40 X-ray binaries. These are intense sources of X-rays comprised of a black hole or a neutron star that feeds off a stellar companion. According to astronomers, the results will ultimately help researchers better understand the role of X-ray binaries in the evolution of our universe. These energetic objects may play a critical role in heating the intergalactic sea of gas in which the very first galaxies formed. Now, other space missions, such as NASA's Chandra X-ray Observatory, have obtained better images of Andromeda at lower X-ray energies than the ones detected by NuSTAR. But the combination of Chandra and NuSTAR provides astronomers with a powerful tool for narrowing in on the nature of the X-ray binaries in spiral galaxies. In X-ray binaries, one member is always a dead star of some kind: neutron star, white dwarf, or maybe a black hole. Under the right circumstances, material from the companion star can spill over its outermost edges and then be caught by the gravity of the black hole or neutron star. As the material falls in, it's heated to blazingly high temperatures, releasing a huge amount of X-rays. With NuSTAR's new view of this piece of Andromeda, astronomers are working on identifying the fraction of X-ray binaries harboring black holes versus neutron stars. That research will help them understand the population as a whole. Next, and I'm quoting here, a globular cluster might be the first place in which intelligent life is identified in our galaxy, unquote. That was from astronomer Rosanne DiStefano of the Harvard-Smithsonian Center for Astrophysics at the 227th meeting of the American Astronomical Society. Now, as Jon Stewart would say, go on. Our Milky Way hosts about 150 globular clusters, most of them orbiting in the outer edges. They formed on average about 10 billion years ago. And because they were formed so long ago, their stars contain fewer of the heavier elements needed to construct planets, since those elements, like iron and silicon, must be created in earlier generations of stars. Some scientists have argued that this makes globular clusters less likely to host planets. In fact, there's only been one planet found in a globular cluster so far. But DiStefano and her colleague Alec Ray argue that this way of looking at it is a little too pessimistic. Exoplanets have been found around stars that are only 1/10 as metal-rich as our Sun. And while Jupiter-sized planets are found preferentially around stars containing higher levels of heavier elements, research finds that the smaller Earth-sized planets show no such preference. So they're saying it's too soon to tell if there are no planets in globular clusters. Another concern has always been that a globular cluster's crowded environment could threaten any planets that do form. For example, a neighboring star could wander too close and gravitationally disrupt a planetary system, flinging planets into interstellar space. However, a star's habitable zone varies depending on the star, and while brighter stars will have more distant habitable zones, planets orbiting dimmer stars would have to huddle much closer. Brighter stars also live shorter lives, and since globular clusters are old, those stars have long ago died out. The predominant stars in globular clusters now are very faint, very long-lived red dwarfs. Red dwarf lifetimes are measured in trillions of years. Now, if you want to learn more about red dwarfs, watch my video, The Embers of Creation. The link to that is below. Any potentially habitable planets they host would orbit close to the red dwarf and be relatively safe from stellar collisions or any other interactions like that. According to the team, quote, once planets form, they can survive for very long periods of time, even longer than the current age of the universe, unquote. So if habitable planets can form in globular clusters and survive for billions of years, what are the consequences for life should it evolve? Life would have ample time to become increasingly complex and even, potentially, develop intelligence. Such a civilization would experience a very different environment than our own, though. For example, the nearest star to our solar system is 4 light years, or 24 trillion miles away. In contrast, the nearest star within a globular cluster could be about 20 times closer, just 1 trillion miles away. This would make interstellar communication and exploration significantly easier. Quote, we call it the globular cluster opportunity, says Di Stefano. Sending a broadcast between the stars wouldn't take any longer than a letter from the US to Europe in the 18th century. Okay. She also says that, quote, interstellar travel would take less time too. The Voyager probes are 100 billion miles from Earth, or 1/10 as far as it would take to reach the closest star if we lived in a globular cluster. That means sending an interstellar probe is something a civilization at our technological level could do in a globular cluster. The closest globular cluster to Earth is still several thousand light years away, making it difficult to find planets using telescopes like Kepler and the upcoming TESS mission, particularly in a crowded cluster's core. But it could be possible to detect transiting planets on the outskirts of globular clusters. Astronomers might even find free-floating planets through a method called gravitational lensing, in which the planet's gravity magnifies light from a background star. Another cool idea will be to target these globular clusters with SETI, looking for radio or laser broadcasts. Something worth trying. Imagine a civilization looking up into a night sky packed with stars. Stars that you could figuratively throw a stick at. Very cool. Well, that's it for this week, Space Fans. Thank you for 4 years of following and watching Space Fan News. I also want to thank those of you who have become Patreon patrons. Your support really goes a long way to making this series just like downtown. Till next week, as always, keep looking up. Astronomers might even find a free-floating planets through gravitational lending. Gravitational lending.